NASA was fueling the giant external fuel tank when engineers noticed the sensor failure and scrubbed the launch. Those sensors play a vital backup role in shutting down the main engines. A malfunction could lead to a premature engine shutdown.
It is a redundant system, but it is a system that's critical to us, and so we certainly want it to operate and to go fly.
It's a problem NASA has seen before. In the first launch after the Columbia disaster, sensors failed and the launch had to be delayed for more than a month. So, like they did then, engineers are now inspecting the sensors and the wiring, this time hoping they can troubleshoot the problem on the launch pad and try again tomorrow.
We've got to do some additional engineering analysis and evaluation.
NASA is anxious to get Atlantis on its way, trying to keep up an ambitious construction schedule. When it does launch, Atlantis will be carrying the new Columbus module, a school bus-sized European laboratory the shuttle will leave behind at the International Space Station. But spaceflight, it seems, is never a sure thing, and engineers must now figure out the problem with those faulty sensors to get Atlantis off the ground. Kristen Dahlgren, NBC News, Kennedy Space Center.
The failure was a LH2 low-level liquid sensor, and folks are probably familiar with those. We also refer to them as our eco sensors. And we had a failure of sensor number 3 and number 4. And in the system, we have a total of 4 sensors. The failure occurred during tanking around 16 minutes into fast fill. We picked it up while implementing our standard checkout of the system. We were at a point in the test where we send commands to take all 4 sensors dry. And when we did that, sensors 1 and 2 went dry as expected, and sensors 3 and 4 went wet. And right then we knew we had an issue. Preliminary indications are that we have an open circuit there. But again, we've got to do some additional engineering analysis and evaluation to see if that is the problem. And then more importantly, where that open circuit is, whether it's a connector or a splice line or something of that nature. And once we isolate that, then we can determine the appropriate corrective action. Well, the sensors, as a set, are a redundant engine cutoff system. The flight software, and the engine controllers run the engines through ascent, and at the proper time, they've got timers. At the proper time, they'll cut off the engine. And this is a backup to that. If for some reason we're depleting LH2 faster than we had thought, when these sensors go dry, they will send commands to cut off the engine to ensure that we have a safe engine cutoff and our LH2 quantities don't get too low. So it is a redundant system, but it is a system that's critical to us. We've collected a great deal of data through our troubleshooting, and engineering folks and the subspecialties are looking at that data now. The plan is to get that collective technical team together at noon today and look at all our options, and then based on those options and narrow them down to the ones that are best. We are currently in stable replenish, and in that configuration, it is safe to send folks out to the launch pad. So in order to get an idea of how the tank is performing in terms of ice and the foam, we did send our final inspection team out to the pad, and they are going to do a expedited inspection. The team remains in good spirits, and we really are confident that we can work our way through this and get a few launch attempts in this window. So we still have hope and reason to believe that we're going to get off in December, and that's where we're all shooting. And again, we're confident we'll get there.
For more, log on to www.nasa.gov/shuttle.